So this next lesson is about transferring energy by electricity. Before we get into the ins and outs of energy transferring by electricity, I think it's important that we recap the different energy stores as well, as this is an area that often a lot of students find very challenging and also may have had some misconceptions about in the past, and it's really important that you get these basics right in your GCSEs so that you don't lose any marks. So we have 8 different stores of energy. They are on the screen now: chemical, kinetic, gravitational, elastic, thermal, magnetic, electrostatic, and nuclear. There are also 4 different types of energy transfers, which we'll come to afterwards. But I'm going to run through these 8 different energy stores to start with, so that you can see what exactly they all mean and some examples of them as well. So chemical energy is anything that is a store of energy that could be released by a chemical reaction. So food comes under that category, along with any kind of fuel, so petrol in your car, or coal in a fireplace. Also, batteries store chemical energy because there is a chemical reaction occurring inside them when you create a closed circuit. Our next one is kinetic energy. Now, anything that moves has a kinetic energy store. It doesn't matter how slowly it is moving, as long as it is still moving. Obviously, the slower it's moving, the less kinetic energy it will be storing. So a snail is going to have a lot less kinetic energy than a cheetah, for instance. However, they do both have kinetic energy. Next is gravitational energy. Now notice that we don't have to say gravitational potential energy. This is something that changed in the syllabus a couple of years ago, so something to be aware of. You won't necessarily get marked down for saying gravitational potential energy, but it's not necessary for it to be there at all anymore. Anything that is above ground level has gravitational energy. So that could be a book on a bookshelf, it could be your pencil on your desk, it could be you sitting on your stool, because you probably are sitting slightly above the ground with your feet not actually touching the ground in a science lab. Then we've got elastic energy. Again, notice we don't have elastic potential energy. Same reasoning, everything essentially is a potential store now, so it just seemed silly for us as physicists to keep that word in when it really had no meaning anymore. Anything that is stretched, or for that matter anything that is compressed, has elastic energy. So that could be something like a sponge where you've squashed it and it's going to spring back, or it could be something like an elastic band where you've stretched it and it will spring back. Anything where it's going to move back to its original shape will have elastic energy. Next then is thermal energy. Now, in terms of theory, anything that has a temperature above absolute zero, which is minus 273 degrees Celsius, is a store of thermal energy. Obviously, though, we don't tend to talk about that object having thermal energy until it gets to the point where actually we consider the object to be warm. The hotter it is, the larger its thermal energy store. Next, we have magnetic energy. So whenever you have a single magnet, that doesn't have magnetic energy. Magnetic energy occurs when you have 2 separated magnets, or a magnet and a magnetic object, such as a piece of iron, and they are either attracting or repelling each other. At that point, you have a store of magnetic energy, because you have the potential for that thing to be attracted or repelled. Next then, Very similar to our magnetic energy is our electrostatic energy. This is not the same as electricity. Very important. You'll notice there isn't actually such thing as electric energy, and this is incredibly important in this topic, that you realise this as well. There isn't an electric energy. So electrostatic energy is when you have two different charges and they're either attracting or repelling each other. Examples of those are if you had two ions, a negative ion and a positive ion, and they were being attracted to each other, or a proton and electron being attracted to each other, but also things like static electricity are examples of electrostatic energy, because you have the static charges on the two different objects that will be attracting or repelling each other. Then our next one is nuclear energy. Now again, nuclear energy is one that students often get mixed up with. Now, nuclear energy is only stored in things that could have a nuclear reaction. That is not a chemical reaction. So nuclear reactions are where you've got fission or fusion occurring. So places that occurs are in the sun and in all stars for that matter, inside certain types of nuclear bombs, well, all types of nuclear bombs, but not standard bombs, and also inside nuclear power plants. So what I'd like you to have a go at now is you have got a sheet that has a table, blank table for you to fill out. On here we have got 15 different examples of objects. What I would like you to do is try and put these things into the different categories as examples of those 8 different energy stores. Now, some of these will fit into more than one, so you can add it to more than one if you wish. And if you pause our video now to have a go at that, I recommend you spend a little time over it, maybe 5 to 10 minutes, so keep an eye on the clock and have a go at that. So here is the completed table. I have only put them in the category which is the majority of their energy, so it is possible you may have put these in more than one category. I've put them in their sort of key one. So then, as I said at the start of this, there are also 4 ways of transferring energy, and this is where our electricity comes in, because the first way is through mechanically. So this is where you have a force and it moves something through a distance. That's a way of transferring energy between our 8 different stores. Then you have got via electricity, so it will be transferred electrically, and that's when you've got a charge moving through a potential difference, as we have been doing in this topic. Our third way is via heating, and that's where you've got a temperature difference causing a transfer of energy. And finally, you have got by radiation, and that includes all of the electromagnetic spectrum as well as via sound. So again, not only do we not have electrical energy, but we also don't have light energy or sound energy. None of these are now accepted at GCSE. So it's really important that you think carefully about your system and which of the 8 energy stores we've just come across they really fit into. So here is a gap fill for you to have a go at. See if you can work out what the different energy stores are and the way it is transferred. Copy it out, fill in the gaps, pause it now so that you have a chance to have a go. Okay, and here are the final answers, so make sure you have that down in your notes as an example for yourselves.